In this video, I want to review with you the various subshells or orbital types that electrons are housed in. Okay, let's remember that an orbital is a three-dimensional space that has a high probability of housing electrons. Okay, it's the space around the atom, around the atom's nucleus, that is home to the electrons. Okay. Now, when we're looking at the atom and the arrangement of the electrons, okay, there are four subshells, okay, or orbital types that electrons are commonly found in. And I've got them labeled here for you: S, P, D, and F. Okay, and so let's walk through some of this. Okay, let's start out by looking at some pictures. Okay, a simple s orbital, okay, is just a spherical type shape, okay, that houses electrons. And let's remember that every orbital, regardless of its shape, its size, its complexity, each individual orbital only holds a maximum of 2 electrons. Okay, so this is what s orbitals look like. Okay, let's take a look at what p orbitals look like. Now, notice the p orbitals, okay, they look kind of like a bow tie, or I've heard some people describe them as dumbbell shape. I've heard some call them dumbbell shape, but I like to look at them as bow ties. Okay, and notice that there's 3 different arrangements or 3 different orientations of those p orbitals. And let us remember that each orbital, regardless of how complex its shape or how unusual looking its shape may be, it will only hold a maximum of 2 electrons. Okay, of 2 electrons. Okay. And then I've got a picture here of d orbitals. Okay. Now, d orbitals, again, a little more complicated. Some reference them as like clover, 4-leaf clover shape. Okay, and notice with the d orbitals, there's 5 different arrangements or 5 different orientations. And if you notice the way they're lined, the orientation references which x and y and z axes the lobes there are lined around, okay, is what they are referencing. Okay, so there's 5 different ones, and again, each individual orbital that you see there only has a maximum of 2 electrons. And then the f orbitals, I don't have a picture of those, but they're much more complicated shaped, and there's 7 different orientations that they have. And again, each one only holds 2 electrons. Okay, each individual orbital only holds 2 electrons. Okay, so when we look at an element and we start to arrange those electrons, okay, we find that as we move further away from the nucleus, okay, the first shell or the first energy level, on that level we only find an s orbital, okay, and that s orbital would house 2 electrons. So on the first energy level, we're only going to find a maximum of 2 electrons. Now, when we move to that second energy level, that second shell away from the nucleus, we notice that we find the s orbital again. So 2 electrons there, but we also find the p orbitals, which are those that I reference as bow tie shaped. And there were 3 different arrangements, okay, 3 different orientations of those p orbitals again. See, the x, the y, and the z axis of those. So each one of those would hold 6 electrons. So this would hold 2 electrons maximum. This would hold 6 maximum. So our total maximum on the second energy level is 8 electrons. Okay? Then when we reference the third energy level, we move the third shell away from the nucleus, we find the S, the P, and the D orbitals. Okay, those 3 subshell types. So these again hold a maximum of 2 electrons. The 3 various P orbitals would hold a maximum of 6 total. And then the D orbitals, let's remember that there were 5 arrangements, 5 orientations. So that would give us a maximum of 10 housed in there. So we have a total of 18 electrons found on the third energy level. And then when we move to the fourth level, we again have the 2 electrons from the S orbital, the 6 from the P, the 10 from the D, and then from F, notice we're increasing by 4. We're going to see 14 electrons maximum there, because if I had a picture of the F orbitals, you would see that there's 7 different orientations, 7 different directions. So we have a maximum of 32 electrons on that fourth level. Now, a little side note. The max number of electrons on an energy level, on a particular energy level, is equal to 2n squared. So if we 2n squared, 2n squared, 2n squared, 2n squared, we get these numbers right here, 32, 18, 8, and 2. Now, what is unique about the periodic table is that it shows us where we find these orbitals, these subshells, S, P, D, and F, utilized. Okay, so on the periodic table looks like 4 large puzzle pieces stuck together. Well, what we see is that these first 2 groups of the periodic table are where the S orbitals are utilized. Okay, notice 2 columns. Then the P orbitals over here, okay, 1, 2, 3, 4, 5, 6 columns, 6 electrons for the P orbitals, so that's where they're housed. Then this middle region here, that's an orange color, there's 10 columns across it. That is where the D orbitals are utilized. And then down here is where we would find the F orbitals utilized. So the periodic table shows us the arrangement of these orbitals and when each one, S, P, D, and F, are utilized. Okay? So, see, here is a periodic table that's completed for you, and you can see how this is blocked into 4 sections, and our template here showing the orbitals being aligned. Okay? So we can use this periodic table to show us the utilization of the orbitals and which ones each element are maximizing. Okay,